In this home movie, I'll show you how OzGIS allows you to classify your data and display it on a map, a process we call quantisation. It's probably the major way you display maps to help you understand your data. So let's do just a standard choropleth map, and in this case I'm going to use some data downloaded from Stats New Zealand, and here's a little choropleth map, and by default it's classified using a quantisation method called equal value intervals. And this is sort of the default standard method because the way your zones are coloured reflects the way your data is distributed. So this way you can see you've got one little point out here, and as shown on your legend, and it's around Auckland, and otherwise most of the data is squashed down to the bottom end. It's all pretty, these zones are pretty similar data, and there's some excluded data on the map too. So there's lots of ways you can colour your map. So for example, you can use, say, quantiles, and things like deciles or quintiles or whatever have been a very common way of colouring maps. So we now get our census population, and it's changed. Now deciles, quintiles, or whatever the feature is, you get equal numbers of zones in each class. Now what's good about these maps is that when you get a map with sort of equal numbers of zones with the same colour, then you get roughly equal areas of colours on maps, and such maps are very pretty. They look nice. What's wrong with them? Well, if you look at the distribution, you can see out here we've got one point which is extremely different from the others, and so you'd conceptually expect that data point would show up by itself, but it doesn't, because they're all added into this one top color, and as you can see there's quite diverse values here, but they all look the same on the map. Conversely, if you're a supplier of data, then this may be a very good method for you, because if you look at a distribution like this and you've got an extremely different point out here, you might start wondering just how good the data actually is. So if you're a supplier of data and your data's all a bit sus, then this could be a very good way of displaying it. And especially if you go into the features on the map and get rid of this diagram, then beauty, it looks really good when you're trying to market your data. Now conversely, to get sidetracked, one of the sort of basic assumptions is that your zones, your polygons, whatever in a zone, are all fairly similar. Now this is not always the case. For example, in Australia, a country where the vast majority of it is desert, and where no one in their right mind would live, you get a lot of areas where there's practically no population. So in a lot of cases you may want to normalize your data by dividing it by total population, for example, or dividing it by the areas of zones, and you can quite often get areas out of shapefile data and so on to normalize it. Anyway, to get back to deciles, quintiles, whatever, I certainly wouldn't recommend that you ever use it. Now, other sorts of methods we have. You can type in the intervals you want on the map. You can use, for example, refined equal value intervals, and here all that happens is they select nice sort of intervals on your map. Now, if you're doing an atlas or something like that, you may want this sort of thing. If you're analysing your data, then you're usually interested in real values. Other methods, you can use pseudo-continuous colour, where you're using some sort of gradation in the colour to help you understand how the data is. And so perhaps if we select population change or something, you might see this in a better way. You can change numbers of classes if you like, if you want to change the legend, but there's various other types of quantization methods. For example, you may look at your distribution and say, it's sort of bell curvy, normally distributed, so you may want to decide to step out around a mean. So for example, you can put it by default a half and one standard deviation out from the mean, and you've classified it there. And so if you want to for example have a look at what you've got, you can put mean and standard deviation on the map, and as you can see it's split it at the mean, and I think we chose half a standard deviation out. Okay, we'll just pull that off. Okay, other quantization methods, nested means, natural breaks, to look at sort of where the data jumps or there's a step in it, and as you see, it's split it where the biggest sort of steps in the data are. You can put in percentages of zones and classes. Interactively select class intervals if you want. So it's number of classes, and you select the intervals. You got 4 classes, 3 intervals. So we decide to split it, say where there's sort of steps in the data, perhaps. Okay, so interactively do it. And there's various other things. You can also fix the legend in various ways if you want to. So if you're doing a whole series of maps for say an atlas or something, you want to fix the method over several maps. And there's various other things, such as you can select your zones and sometimes limit what you're actually classifying over the map. Okay, now I suppose there's 2 main reasons you're displaying maps. One is that you've developed this fabulous set of attribute data and you want to show it to people. So you might be able to going to do a whole series of maps of all this attribute data and put it on your website. But the problem is then that you don't really know what people are going to use it for. So in this case, you want something that's a general purpose sort of method, such as the equal value intervals, and use that as you flick through the attributes. But The major purpose of OzGIS is to help you analyze your data, and then it's a case of choosing the method that helps you understand it, understand your data. So in this case, you may want something like selected number of classes. So often you're interested in the high values or the low values. So you might say, well, all I want's 2 classes, and I'm interested in the high values, say. And so in the top class, I'll put I'm interested in the top, say 5 classes or 1 class or whatever. So let's say 5 classes in the top zone, and there you have it. You've selected the map with 5. It's not a very pretty map, but it's the map that tells you perhaps what you want. Okay, and that's all I want to say about the methods for classifying for your data, and the way you manipulate the map and help you understand your attribute data.